We've so far been doing two main things that have been really good for us in solving these kinds of equations, okay? The two main things have been, does anyone remember what the two main things are? First, we expand. Okay, so yeah, you see all these brackets, you're like, get rid of the brackets, okay? And then we collect like terms. That was the second thing. Excellent. Okay, now, when you look at this, we are going to do both of these things, but they've added an extra layer of complexity. That's why the heading is more complex equations, which means that before we get to these, we've got to do something else, okay? What's the difference? What extra thing have they added?
The fractions.
Fractions, right. Now, let me put this to you. If I can somehow get rid of these fractions, then I'll be back into a situation where I can do these and I'm home, okay? So how do I get rid of fractions? Well, I'm going to need to do some multiplication because a fraction is about division, right? So to get rid of them, I'm going to multiply by something, yeah.
6.
Okay, now, I am going to multiply by 6. I'm going to multiply this side by 6, which means I'd better do the other side. But a question which you need to ask is why 6? Yeah, Kyle. I will expand it, but first I'm going to do you'll see why in a second. Why 6? It has to do with these two numbers, right? Okay. So number one, you might have noticed, 2 times 3 is 6, that's cool. But more specifically, it's this important idea, it's the lowest common multiple. Okay? No, multiple. Factors are different. You're thinking of highest common factor, which is a little bit different. Okay? So this is an important idea. It's so important you need to write it down, okay? 2 and 3, I want to get rid of both of them in one fell swoop, okay? The way you do it is you multiply both sides by the lowest common multiple of 2 and 3, okay? So watch what happens. Let's do this, okay? If I do this over here, okay? Do you agree with me, just let me put this over on the side here, that 3x plus 1, right? That's the, over 2. That's the same as 3 over 2 x plus 1. Is that okay?
Yeah.
I've done the division over here, but it's the same thing. I'm still dividing it by 2, okay? So therefore, I'm going to write it like that. It's going to make it a little simpler for me, as you'll see in a second, okay? So what I've got is that 3 over 2 x plus 1 there. That's over there. I'm going to do the same thing here, so I'm going to get 5 over 3 x plus 1, okay? But I multiplied everything by 6. Everything by 6, okay? So I multiply this by 6. There's one. And then I multiply this by 6. Okay, now stop. Make sure you know what's going on, okay? This is just like this situation. Okay? You know when you're doing expanding brackets, it looks really hard because there's always awkward numbers there. But you guys know how to do this. This is just normal expanding. This is 6a plus 6b, right? You got to do 6 times both. It's not 12ab because the a's and the b's aren't going to mix it. So, there's my 6a out the front. There's my 6b. Okay? So all I've done is expand over that side. Okay? Before I deal with that, we should deal with the right-hand side as well. So 4 times 6. Just a second. 4 times 6? 24. Okay, question.
Couldn't you collect like
I will shortly.
it's a bit easier.
Hold on.
Sorry, X's.
Yeah. I will. But I've got these different denominators, which is a problem.
Why does that? That's over different.
I'll fix it up. Watch. So here's what I'm going to do. Okay. Can you see that? 6 times 2, there's going to be some cancelling happening over here. Right? Some cancelling.
Cancel the 6.
What's going to cancel? What am I going to divide through both of these by?
6.
Can I divide 2 by 6?
Yes.
2.
I think I'm going to divide by 2.
Yeah, that's what I meant.
It's going to become 1, and that's going to become 3. Is that okay?
That's what I meant, yeah.
Yep. So I'm going to get 3 times 3, which is 9.
Fine.
Right? Okay, is that right? What happens over here? I can cancel again. 6 and a 3. I can cancel out a factor of 3. Right?
So
It's
that's
going to be
2.
pretty much the exact same.
1.
That's 2. Okay. Do you want me to slow down?
No.
So that's 10 brackets.
2 times 5, that's 10.
Where'd you get 10 from?
Okay.
So that's 2 times
I did a
5.
cut. Yeah, that's right. I did 2 things at once. I cancelled and I multiplied. Okay?
Wait,
Yep.
the 3.
Which number are you talking about? These guys or these guys?
The left one, the most left hand.
Yep. 3
Yeah.
times 3. 9. Cool. Now at this point, this is interesting, okay? And this is what Ali was talking about just now. Usually we expand and we collect like terms, and we usually do it in that order. But this time, I don't actually need to expand just yet. Watch. Can you see? I've got x plus 1s here, right? And I've got x plus 1s here. So can you see that? So I've got, those are like terms. Those are terms that are alike. We're used to seeing a letter there, like 9k plus 10k, right? But it doesn't matter, it can be anything you like. These two x plus 1s, right, they're both like terms. I've got 9 here and I've got 10 here. So when you've got 9 of something and 10 of something, you put them together, you get 19 of them, right? Oop, wrong colour, sorry. 19 lots of the like term, namely x plus 1. Is that alright?
Yep, that's good.
Okay, cool.
That's what I got.
This is really good because at this point, right, I can get rid of this 19 straight away. I can divide them over the other side, right? So if I divide this side by 19, I'll divide this side by 19 as well. Is that okay? Divide both sides. All still okay? I get x plus 1 over here. Okay, now what?
You have to
Minus 1.
I should take away 1 from both sides. Okay, now I've written down 1 there, but we can write it in a more helpful way. I've got to subtract it from 19ths. That's a bit awkward, isn't it? How many 19ths are there in 1?
19.
There are 19 19ths, right? So I'm going to write that as 19 19ths,
Is that the actual?
okay?
It ends up
And so 24 minus 19 is 5.
Over 19. That's confusing. Yeah.
No, it's not. 'Cause I
Okay.
so-
Now, if you like, I can show you other ways of doing it. Like, there's lots of different paths down here. It's just like if you're going from Cherrybrook to the city, there's at least like 10 different ways, major roads you could take, but they'll all get you to the same place in the end.
How
Yeah.
did you get the 19 over 19? I missed it.
This part here? Yeah, true. I went through it quite quickly.
Yeah.
What I had here, how did I go from this line to this line? What did I do? Do you remember?
minus 1.
I subtracted 1 from both sides, so really there was a minus 1 there. But I noticed that, when I have fractions together, I want them on the same denominator, right? I want 19ths, in other words. So that's why I said, well, 1 is the same as 19 over 19. That's where it came from.